This session is for PowerShell Remoting internals. My name is Paul Higinbotham. Unfortunately, with this beautiful weather, my allergies have been flaring up and I'm kind of hoarse, so hopefully you can hear me. It's worth it. It's nice to see the sunshine, but it's affected me a little bit that way. So we're going to talk about PowerShell Remoting internals today. This session, what I hope to get across is give you an idea of how PowerShell Remoting works, how PowerShell executes or runs scripts on remote targets, and a little bit about the PowerShell API that implements PowerShell Remoting. Quickly, the agenda, a bunch of things we want to go through. Basically, I want to keep at fairly high level. PowerShell Remoting is pretty complex and pretty involved, but in a short period of time, I have to probably keep it at a fairly high level. I'll probably throw some things at you fairly quickly. Please stop me for clarification. I'm going to try to stay on track, not get off track. But my intention is to do a demo about partway through to maybe help clarify some of the concepts, and then near the end do kind of a walkthrough of basically running a command from a client to a remote target to hopefully solidify some of these ideas. A little bit about me. I'm a developer on the PowerShell team, actually almost 9 years now. The interesting thing is I came on the team right after version 2 was shipped, and actually the remoting system was written in version 2, so I actually wasn't part of writing the remoting system. I've done a lot of work with the remoting system. I've added to it, added features to it, fixed a lot of bugs, and ended up I now own the remoting system. But it's been around for a long time, and actually I was not part of the original implementation of the system. The other things I do is co-owner of PowerShell Security with another member on the team. So to get started, what is PowerShell Remoting? Essentially, the whole idea of remoting was to implement basically automation, right? PowerShell is all about automation, and so get the first thing out there. The idea is that with remoting, you can fan out scripts, automation scripts to multiple machines, take advantage of PowerShell job infrastructure for concurrency, so all the resulting data comes back and gets collected, and so it really is to support automation. And then also the idea came as well, we can also do some kind of an interactive thing, kind of like remote desktop. You can do a remote shell, right? So you can connect, use an NRPS session from computer A to computer B, machine B, and what you type is actually executed on the second machine, and the results are displayed on the first machine. So you're just like a remote desktop, it's a remote shell kind of a thing. And then I guess maybe the last thing in my mind is also remote script debugging. You can connect from machine A to machine B, run script on machine B, and also debug it real time. The other neat thing you can do with PowerShell Remoting is you can connect machine A to machine B, and then while you're in machine B, you can do a second connect, an internal connect, to any other process that's hosting PowerShell on that second machine, and then debug script on those other processes. So it's pretty powerful debugging potential there. PowerShell Remoting is extensible. This is kind of a busy slide. You don't need to remember all of this stuff. Yeah, it looks busy up there as well. But PowerShell is more than just remoting from machine A to machine B. There's actually 5 implementations of remoting in PowerShell. There's, I'll just go through them real quick. There's the WinRM. It's the one that everybody knows when you do a new PS session. It establishes a connection through WinRM from usually off box from one machine to another. Implemented in both Windows PowerShell and PowerShell 6. Just for PowerShell 6 and for cross-platform support, there's SSH, Secure Shell Remoting. It's fairly new. It's not fully implemented. There's some features that need to be added. It's only PowerShell core where it exists, but the nice thing is it's cross-platform. And those are the two that where you can go off box from machine A to machine B. Then there's 3 other implementations of remoting that are local, that are on box. One of them I call out of proc. It's actually what PowerShell background jobs uses. When you do a start job, what happens is that PowerShell spins off a child process and runs the script or commands in that child process, and it uses a remoting system to communicate between the main process and then the child process. You get nice process isolation that way, but it's fairly heavyweight. Another one called IPC, or Inter-Process Communication Remoting, is fairly new. That allows you on a local box, if you're an admin, you can connect from, say, one shell to any other process that's hosting PowerShell. It's kind of what we referred to before. So you can connect from your shell to process B, and once in process B, you can run commands in process B if it's hosting PowerShell. And the whole point of that is for debugging. The idea is that you can connect from your shell to any process that's hosting PowerShell and then debug, interactively debug script in that second process. And then the fifth one is PowerShell Direct. That, again, is a local machine that allows a host to connect directly to guest virtual machines, not through WinRM. You don't have to have WinRM set up or SSH. It just goes through a Hyper-V socket, and that's, again, just local machine. So that just gives you an idea of just how diverse PowerShell remoting is. And kind of the neat thing is that everything about PowerShell remoting layer is all constant. The only difference between all 5 of these is the transport. Each one has a different transport to basically you implement that remoting feature. And the transport, of course, is just the logical entity that is responsible for making a connection, however it is, from point A to point B, from machine A to machine B, from process A to process B, and do any kind of user authentication or accessibility restrictions. So this talk, for PowerShell remoting, as far as it's concerned, transport is just an interface. And so this talk is just talking about the PowerShell remoting, not really the transport. Transport is kind of separate. So we're going to stay focused just on PowerShell remoting. So how does PowerShell remoting work? Start at a very high level. Just basically what happens is that from client A to some kind of target, a PowerShell basically mirrors a session from the target back to the client, right? So the client can execute script on the target using API, and we'll talk about it in more detail later, but that gets transferred to the target. The script and commands get executed. The results and data are basically returned through the remoting layer. And all the magic happens in something called PowerShell Remoting Protocol. That's basically this big, huge definition of all of the, basically what protocol does is define the messages and data that flow back and forth across the transport, across the wire, and actions that need to be taken in response to those messages. And again, PowerShell remoting is transport agnostic. When you set up a remoting session, you basically hand or indicate to the remoting system what transport you want to use. And so looking at the diagram, it's a little bit busy, but this is the same kind of pattern that you always see, or that I always will display in this talk. You basically have a client up at the top. Within that client, there's a session. Within the session runs a command, and then there's a transport layer, and then on the bottom is the target. And within that target, the actual session that runs a command is created, and then the command is actually run there. So in the client, when we say there's a session, components and command components, they're actually proxies. They talk, they don't really do anything on the local box except talk to the target and relay information back and forth and direct the target how to execute the command. So that's just at a very high level. So the best way to look at PowerShell remoting is, I think, is through the API. Of course, normally you access it through commandlets, but underneath commandlets they use the same API. So it's a good way to understand what PowerShell remoting is doing by looking at the API. And the remoting API is actually connected very strongly to the engine API. So how the remoting executes script remotely is very similar to how script is executed on a local machine. It's just basically abstracted out for a remoting situation. So in order to understand PowerShell remoting, executing scripts, you have to kind of understand how scripts are executed locally. And so I just want to spend a little bit of time talking about that. And there's like 3 main ideas you need to keep in mind when you're thinking about running PowerShell scripts. The first one is something called a RunSpace. I'm not sure where that word came from. I've been doing this for so long, it's just natural to me, but really what a RunSpace is a PowerShell session. And you think of a session, a lot of times when you open up a PowerShell window, a console, you have a PowerShell session. Well, it opens up the console with a default session. So when you type in it, that's the session you have. But PowerShell supports any number of sessions. You can create multiple sessions, and the reason you might want to do that is for concurrency or something. You can be running multiple scripts concurrently, each in their own session. So RunSpace is synonymous with session, more or less. What it is, it's the context in which commands, or I guess we call it command pipeline runs. What that means is any modules you import, any function you define, variables that are defined, it's all within that run space. So that's the context in which the scripts can run, multiple scripts and commands. And you can also think of it as an isolation layer, right? So you can be running scripts in different sessions and they don't affect each other. They can't directly talk to each other, they're isolated. So that's the context in which script runs. And then the next thing is, how our command pipelines run. So how do you then run a command pipeline? The way that works is there's something called a PowerShell class. And I'm going to demonstrate this in just a minute to help hopefully cement this. But the PowerShell class encapsulates all the information you need for a command pipeline. It can be multiple commands. It can be parameters that are bound to whatever functions or commands that you've defined in it, handles data streaming and all that kind of thing. So it just encapsulates it all together. And then the idea is that the PowerShell object that encapsulates the pipeline, command pipeline, runs, you associate it, runs against a run space. And so that's the kind of the concept there. And then finally, for remoting, the big thing is object serialization. PowerShell is object-oriented. Everything is about objects. So, how are objects passed back and forth? And it's just basically it's a serialization system. So when you're piping data from the client to commands or script you're running on a target, the objects get serialized on the client, deserialized on the target, and then back the other way too. When the target generates data, serialize and deserialize. Questions? That's good. So then I want to just take a minute demo to hopefully solidify some of these ideas. Just how to use the API, and of course, PowerShell, you can access APIs there, so we can run APIs on a local PowerShell and just see kind of how this works. So you can actually, execute a script through the API locally, and then how you do it remotely. So we'll just start here. This is a clean PowerShell console session. And if we type get RunSpace, we see that there is one RunSpace, one session. And this is the default RunSpace or session that is created for you automatically when you open up a shell. You can see that the type is local, so it's not remote. It's open, and the availability is busy. It says it's busy because it's running this command when it gets that information. So we talked about the PowerShell object. There's a static create function on a PowerShell class. When you take a look at it, basically it just creates the class. And so to kind of build a command to execute, you start by creating PowerShell object. You take a look at it, and you see there's property for commands. So all the commands in a pipeline, including scripts, you can go into this property. There's something for streams that handles data streams. Something called invocation state info. This is the state of the command as it's running. And then there's something here called RunSpace, which is what we talked about. So this is the session. And you can see that it actually created one for you. If you don't specify a run space, it just creates one. And it's a local run space, right? So now if we do a get run space again, we see like, oh, there's two run spaces. There's the default one that we had before. Now there's this second one that's been created. Again, a local run space. State is open, availability is available. It's ready for commands to be run. So then the next thing you do, okay, so we have a PowerShell object. We have the run space that was created for us, a local run space. Now you can just go ahead and add, oops. Oh, actually, I just want to demonstrate this real quick. If we do a get member, just look at this PowerShell object a little bit more. There's methods to add commands, add parameters, add arguments, add script, all kinds of things to build up your command pipeline. And of course, it's and some other things in there as well. And of course, it's got a run space property so that you can associate a session for that command to run in. So then we're just going to add a simple script. I'm just going to get the process ID or the process of very simple. If you take a look at the object and at the commands property, see that it's there. And then to now execute this command, this script, we just do an invoke. Okay, and then what this does is invokes it synchronously, and then when it returns the process object that you expect. And if you look at the process object a little more closely, we see that it's an actual process object, system diagnostic process. It's live. It has methods that you can run on the process. You can even kill the process. So it's just a live object on the system that you can that you can use. So okay, so that's how you execute or how you run commands locally. Now the question is, how then do you run commands remotely? And so the only difference here is that you provide the PowerShell object a run space that is a remote run space. This is a run space that is associated with a remote connection. Now, in order to do that, there is something called a, actually, I think the best way to show it is to create a run space. There's a space factory object that has static create run space method. And there's a bunch of them for creating different kinds of run space, but we're interested in creating a remote run space. And so the overloaded create run space method that we want to use takes something called a run space connection info object. What that is an object that defines a number of things, but two main things are what type of connection you want to make, what kind of remote connection you want to make, and also information on how to make that connection. Things like user account information and, of course, target computer and other pieces of information, depending on the transport that's used. And as I mentioned before, there's like five implemented transports right now, 5 implemented remoting solutions implemented in PowerShell right now. And so there's a derived run space connection info object for each one of those. And so the idea is that when you pass that particular object in to this run space factory, it will see what kind of object it is and then build up the object with the correct transport and everything so that it can make that type of connection that you want to do. So to demonstrate that, I was going to do SSH, Secure Shell Remoting, but I'm having trouble connecting. I don't know why here. So instead, I'm just going to use a local IPC connection. And so what I'm going to do is I'm going to connect from this shell that we see here, and I just opened up, I think this one here, just another shell that's hosting PowerShell, and has a process ID 12700. So I'm going to make a connection from here to that process that's hosting PowerShell. Whoops. So in order to do that, I start by name pipe connection info. So this name pipe connection info object is a derivation from a run space connection info object, and this is used to create connection information between processes using a named pipe. If we take a look at it, it takes a number of things, but basically what we care about is passing in the process ID. And what did I say it was? 12700. And then passing 12, I guess it's 700, right? Okay, now that's created that object. Let me take a look at it. The important thing here is really the process ID. So that's what that specifies. Now, using that, we can create a RunSpace, and we pass that in the RunSpace creation API. It will see that as a named pipe type object and create that kind of RunSpace for it. So now we can create a RunSpace. Factory. You can optionally pass in the host. This is a host of this shell, so that any host calls don't really need it. You can pass in null, but I just do that. Then pass in the connection info. Now if we do a get RunSpace, you see we have a third one. Okay, now we have a RunSpace that's been created. It's a type remote. But the state is before open and availability is none. So what this has done, this has just created stuff on the client. This is all client-side stuff. Everything's all set up for the connection to the remote target. In order to actually start that connection, initiate that connection, you use the open method on the RunSpace. So when you call that method, it initiates the connection. It does any kind of accessibility check. For instance, you can't just connect from one process to another unless you're running as an admin or something like that. It actually does a bunch of things, and this is at the transport level. So it not only gets a connection started, but it also establishes a PowerShell session in that target. In order what you run a script on, just needs the session that to be created. We'll talk about it in more detail in a minute. Oops. I don't want to get ahead of myself. So I just did the open. It's very quick because it's local. Now you see, okay, everything's there. State is open. Availability is available. And then the last thing you do is you just now associate it, the remote RunSpace, with the RunSpace on the PowerShell object that contains the command you want to run. So we do that, and then now we invoke synchronously. And now we get the process object again. If we look at the process object, it looks the same. But if you look at it more closely, oh, another thing too is as we expected, the process ID is 12700 because that's the process that we connected to. But if you look at it more closely, let's see, the get member, we see that what we get back is not a process object, but a deserialized process object. Okay, so this is the whole serializing, deserializing thing of the PowerShell remoting system. So on the target process, it gets the process object, serializes it, sends it to the client, and then deserializes it. And this is not a live object. I mean, the only two methods that we have are getType and toString. So this is really just like a snapshot of that process at the time it was serialized. And this is basically just a PowerShell custom object with properties. PowerShell does actually on the serialization system, when it does deserialization, there are some types that it recognizes and creates an actual instance of when it can do it correctly and safely. For instance, PS credential, when it goes through the remoting system, there's details there, but basically the actual credential instance object is created on either side after it gets deserialized, and it's called rehydration. The only other thing I want to demonstrate real quickly, running out of time, is that the serialization system you can play with at any time. You can access it through commandlets. For instance, there's an export CLI. I'm not sure where that name came from. So it's just going to take that proc object that's a live object, and it's going to serialize it into an XML file. And it's the same serialization that PowerShell does, and you see that this is the XML of the serialized object. It's got type information, the kind of type that it's representing, and a ton of properties. And you can see for a process, it's huge. It's just, all the modules are loaded into the process, and everything is there. So that's as far as I want to go for the demo on this. Then I want to get back to talking about what's actually going on and maybe get to the walkthrough of what's actually happening. So we can see in the API how to create objects and execute script and commands over remoting layer, remoting boundary, but what actually happens. So we're getting into a little bit of details. I won't dwell on it too much, but this is the way I think of remoting architectural and conceptual layers. Everything starts with the transport that I talked about already. The transport obviously defines, how the connection is made and how data is passed back and forth and all that sort of thing. On top of that is the remoting protocol that defines what messages there are and data associated with those messages and actions, in order to implement remoting. Then there's the small protocol, just for completeness, I added in for remote debugging that works on top of the remoting protocol, and that implements script debugging. And then the PowerShell serialization system, so obviously going to be passed back and forth, talking about that. PowerShell remoting implementation, that's a huge bucket that we can talk about a little bit more. And then on top of that is the engine implementation that actually runs the script, actually executes scripts in the engine. Just real quick on the PowerShell Remoting Protocol. Again, we already talked about it. Defines messages and data over the wire, specifies actions to be taken. This is all documented. Microsoft, all protocols have to be documented in very informal way with using normative language. And if you're interested, you can look up the document's called MS-PSRP. It's very comprehensive, very long, very dry, but it has all the information. In theory, you can implement PowerShell remoting based on that. And there's one both for the remoting, and then there's a small one for the remote debugging, if you're interested. So just to recap real quick, basic remoting concepts we're looking at. The RunSpace connection info defines what the transport is, what kind of connection, what kind of remoting connection that you're going to want. And we actually, I couldn't get SSH. I was going to do SSH, but here it's the same thing we did, except not with name pipes. This is SSH connections that's being created. And then in order to, and then you create a RunSpace. You pass it the connection info object that tells it, what kind of transport to use for the remoting session. Command pipeline, you associate the RunSpace session with a command pipeline, and then you can execute that command pipeline on that RunSpace. And again, the object serialization so that data can be passed back and forth. So this is supposed to be internals and a deep dive. I'm not going to spend too much time here because it's a really busy slide, but I just want to put something up here that sort of summarizes all the things that we kind of talked about already. But the components are, we've already talked about these. The transport manager, those are the objects in PowerShell implementation that talk to the transport, that basically implement the transport. It's divided up between client and server, client and target, and session and command. That's kind of a pattern you see all the time. Serialization, we talked about that. Protocol implementation, again, there are components on the client and symmetrically components on the server, and then a split between session and command, because on session you can have a number of commands that can run. RunSpace connection info, we talked about that, the different ones that already exist, and there may be some new ones in the future, PowerShell RunSpace and PowerShell command pipeline. Okay, so finally, I wanted to get to hopefully, if it's not real clear, help maybe make this a little more clear, kind of walk through what happens. So we already, in the demo, we're already, typed in commands and used the API to execute remote script on a remote target. And now I just want to go through and just see what happens in each one of these steps. And hopefully it's not too complex. This diagram is kind of similar to the one we saw before. Again, the way it's structured is at the top part is the client, at the bottom part is the target, and then there's a dotted line in between, and that's the remoting boundary, whether it's process boundary in a local machine or boundary between two machines in different countries. And then there's a transport that handles how the connection is made, how data is passed back and forth. And then if you look at each box, the upper left client and the lower right server, they're divided in half. Again, it's divided between session on the bottom and then the commands that run on that session on the top, and the same thing. And again, the whole idea of remoting is that on the client, basically the client causes a session and command to be created on the target, and then the components on the client reflect that. They're proxies. They talk to that and reflect what's going on the remote target. So, oops. There we go. So, invoke command, hostname, target computer script block. Hello. Now we're at the command level. We're not at the API anymore, but of course underneath it's using the API. The invoke command, we're using a parameter set called hostname, so it knows internally that that's SSH, so it's going to create an SSH transport. So what happens when you type this in? So, whoops. So the first thing we kind of talked about already, SSH Connection info object is created because that defines the connection that we want. The RunSpace is created based on that connection info, so it's a SSH, based RunSpace with SSH transport. And then other things, I don't know if we want to get into too much detail here. The connection state machine is created. There's data structure handlers created for implementing the protocol, and then there's transport managers that's created that knows how to, talk to the SSH and do that sort of thing. And again, the RunSpace is open. The connection is initiated. Authentication is done as needed. Negotiations, on capability. What version of PowerShell are you talking to? When all that's done, then the client just basically monitors the state. So if everything is good, the remote RunSpace on the target or the has been established, and everything is good, and now it's ready for commands to be run on it. Just a quick interlude here. When we're talking about talking back and forth between client and target, it's passing data back and forth. It's basically passing data packets, PowerShell Remoting Protocol data packets. I just want to, you don't have to remember any of this stuff, but just get an idea of kind of what you think it is. There's different types of data packets depending on the message that goes back and forth. There's things that talk about is the destination client, is the destination server, target interface, association of IDs, stuff like that. So every time we talk about, the client talking to the server and server talking to the client, these data packets are being passed back and forth that look like that. So that's on the client. On the client, it goes through there that we saw, created the RunSpace, opened it, the connection. So what happens on the target? So what happens on the target is that when the connection is initiated, and the connection is set up, the next thing happens is that the transport then has to establish some sort of a host to host PowerShell. So it establishes the host, starts up PowerShell, configures PowerShell. It can happen in different ways. And PowerShell is run in what we call server mode. It's basically just running a listener loop. And so it can respond to protocol messages. There's some other details like when it creates a RunSpace on the target, it's encapsulated in something called a RunSpace driver. And the idea is that it's running in this context where when it's running, the driver passes information back and forth through the protocol to the client so that the client object RunSpace acts like it's the actual local RunSpace, but it's not. But it goes through this driver thing. And so essentially it gets set up and then it just sits there and it just waits for the command from the client. So it's ready to go, just waiting for a command. So now, invoke command, get back to it. It's established the session. The session is fine. The session is running on the target. It gets an acknowledgement back that everything is good. Then the next is now it wants to run a command. It wants a command pipeline. So what does it do? The way this works is the command pipeline is wrapped, as we talked, in a PowerShell object. Then it's encoded in a custom object. What that is just basically is a property bag. All the information, it doesn't even serialize it. Basically, it just looks through all the properties that that the remoting side cares about that's defined in the protocol, and just creates a property bag about the command, about arguments, binding, just stuff that it needs to know to execute the command on the target. Yeah, so that is encoded in a PS custom object property bag. Then that gets serialized and then sent to the target so that it'll run, so it'll execute. And again, quick interlude, something you don't actually have to know, but this is kind of the data that you see. What you see on the bottom here is the actual serialized PS object that contains the command pipeline information that's being sent to the target. Whoops. And then, as you expect, on the target side, it decodes the command, basically takes those properties and then creates an instance of the PowerShell object, and then actually runs that PowerShell object within, again, this is called the PowerShell Driver. It's like the RunSpace driver, but it runs the PowerShell script, executes the PowerShell script like we did in the demo, except in the context of this remoting the protocol, so that, say, you have data that's being piped from the client, to the target that handles the data stream coming in, and any data that's created on the target that gets passed back to the client. It goes through the driver and gets handled correctly through the protocol. And it's a lot of details there. And then finally, on the client side, it's just sitting there. It's monitoring the state of the command as it's running. Whether it's running, stopped, completed, failed. Again, handling any data that's being streamed back. There's also things like host calls. Direct host calls are handled in the protocol. So if you do like a prompt or something, that gets handled, and stop signal as well. But basically, it's just waiting for it's just receiving data and waiting for the command to complete. And it can optionally send a stop signal if you want, and then that's handled through the protocol. So all that stuff, and all you get is hello coming back. Yeah, that's all the things that happened. And there's maybe one other thing that is, as a software developer, you kind of want to deal with. Things get cleaned up afterwards. And so if you're interested, this kind of talks a little bit about how things get cleaned up. Invoke command just invokes it once, and everything all gets torn down afterwards. So a fair amount of state gets created. You execute the command, you get the data back, then everything's torn down. So that is about as far as I wanted to go on how remoting script gets executed on a remote target. If you have questions, let me know. I was going to then kind of just go into endpoint configuration. What remoting endpoint configuration is because I went over this very quickly, is when you establish the remote session on the target, it creates a PowerShell, or creates a host, and then in the host it creates a PowerShell session. It's actually possible to configure how that PowerShell session was configured, right? Things like how it's hosted, what kind of account it's hosted in, sort of access control, who can connect to it, quotas and stuff, how timeouts and things, how long commands can take. Things like this can be configured in some cases at the host level, and at the PowerShell level. Of course, PowerShell has some powerful ways to configure a RunSpace session, panels that are visible, language mode that we didn't even get to that you run in, available drives, all kinds of things like this that can restrict, what you can do in that remote session. And in fact, our GR, Just Enough Administration, uses that, for creating secure connections to endpoints that are greatly restricted in what you can do, for high-value machines, high-value targets. And of course, the GIA is basically role-based, so it's depending on what group you're in and what account you have, you get these particular privileges, access rights. Currently, that kind of configuration is only supported on WinRM right now, the original remoting solution for PowerShell. But it's something we want to add to the SSH secure shell transport at some point. So anything that's not WinRM transport basically just creates a default PowerShell, which is just wide open. Everything is open in game. And just the things that you can use to look at or to play with configuration, just some commandlets, right? Just a PSH and new PSH configuration, new role capability file. Oops. So that, just about on time. That pretty much is all I wanted to go through for the remoting. It was pretty high level, a lot of hand waving. There's a lot of details. You're very welcome to talk with me afterwards if you want more details about how it all works. But basically, I guess the summary is, the remoting is really fairly robust and very easy to extend. The whole idea is for automation, presuming PowerShell object, the PowerShell data object that makes PowerShell so great. The access to the commandlets and API, and the interactive shell remote debugging, I think, is pretty powerful. And with that, I think that's all I have. If there are any questions. So the question is, in PowerShell 7, will there be endpoint configuration support for SSH? And the answer is, I don't know. I would like to. Yeah, me too. It's something I'm kind of passionate about, but it really comes down to resources, and it's above my pay grade. That's correct. So the question was, can we use RunSpaces for find out scenario where you are pushing high workloads to targets, to servers that are capable of running those workloads and then gathering the data. And yes, that's exactly what, well, that's one of the things that it supports. I think the original idea was for automation management, but that is perfect as well, the idea of pushing out workloads, right? Yeah. Yeah, that's a great question. The question is, how do you keep track of all of these things when you're fanning stuff out, and they're all running, concurrently, and then how do you gather it all and deal with that? And the answer is yes. As you suggested, jobs is a PowerShell way of doing it. I personally think there should be another concurrency model that's different than jobs and maybe easier to use. It's something that I would like to look into, but that's on the horizon. So it looks like our time is up. Thank you very much.